Hey guys, Mr. Barnes here again, bringing another math video. This one on finding the derivative of an exponential that has something in the exponent that's not just x. So where you have to use the chain rule. So I'll do this quick example just to get us started, and then we'll do a couple of harder ones. So y is equal to 2 to the x squared. So we got something other than x. So first of all, you need to remember this little formula that I gave you in a previous video. So if you watch the other video that I have on just basic derivatives of exponentials, you've probably seen this. But the derivative, d over dx, of a to the u, so that u in our case is x squared, is equal to a to the u times ln of a times u prime. So in our case, my u is x squared, so I end up with 2x squared times ln of 2 times the derivative of x squared. So now I end up with 2x squared ln of 2, and the derivative of x squared is 2x. I think I said 2x squared, but anyway. So again, order may not be important. May be important to some teachers. They might have preferences, but I think this is perfectly fine. So that right there is a derivative of 2 to the x squared. So if you have something a little bit more complicated, say y is equal to 3 to the sine of x. So again, we recognize that sine of x in this case is u. So I'll write it one more time. D over dx, a to the u, is equal to a to the u times ln of a times u prime. So in this case, my y prime is going to be equal to 3 sine of x times ln of 3 times the derivative of sine of x. So that's 3 sine x ln of 3 times derivative of sine is cos of x. And there it is. Done. So you might even get something that's a little bit harder than that. So I've actually given this one on a test before. Y is equal to 2 to the x. So you have sort of an exponential within an exponential. So again, nothing changes. I'll write this guy out again. D over dx, a to the u, is equal to a to the u times ln of a times u prime. So we have y prime is equal to 2 to the x times ln of 2 times, now the derivative of 2 to the x. So I have 2 to the x times ln of 2. And remember, the derivative of 2 to the x, we can use this rule. It's no different. We just need to remember that we don't really need the u prime there because it's just at x. So it's 2 to the x times ln of 2. And if you wanted to, you could rearrange this a little bit. Since we got two ln 2's, we can call that ln 2 squared if you wanted to. And you can also combine these exponents. You have the same base, so you could write it as 2 to the x plus x times ln of 2 squared, just like that. So again, guys, if you know this, I think this makes it a lot easier. Then you don't have to be worried about taking a line of both sides all the time. But again, line of both sides works, and I've made a couple of videos if you want to check those out. The only time I would really be definitely using line of both sides is when you have this situation, f of x to the g of x. When you have a function to a function, say like x to the sine of x, something like that. That's where I would use line of both sides. But when you have, in this case, an exponential where it's just a number to a function, I will be using this rule. So I hope this video helps you guys. Thanks for watching, and I'll see you guys in class.